Morning students. Last class we discussed some of the properties on the determinants. Okay. Now in this class we can discuss some more properties. So that is property number 5. So what is the property number 1? Last class we discussed is delta equals to delta dash. Delta equals to delta dash. What is this delta equals to delta dash means? In a determinant, if all the rows and columns are interchanged, then the value of the determinant remains same. Property number 1. Property number 2. Delta 1 will be equals to minus delta. What is this case? In a determinant, if any two rows or any two columns are interchanged, then sign of the determinant changes. Property number 2. In a determinant, if any two rows or two columns are identical, then the value of the determinant is 0. Property number 4. In a determinant, if a row or column can be multiplied by a non-zero number, then whole determinant is multiplied by the non-zero number. That is delta 1 equals to k times of delta. Okay, these are 4 properties we discussed in the last class. So now in today's class we discuss about the property number 5. So what is this property is? In a determinant, if a row or a column can be expressed as sum of SUM, sum of 2 or more terms, then the determinant can be split into 2 or more determinants. Means, see here, let us take one of the example here. Property number 5. Determinant of A1 plus alpha, A2 plus beta, A3 plus gamma, B1, B2, B3, C1, C2, C3. Okay. See, in this determinant, so the first row is the right term. So this is expressed as sum of 2 terms. This is also expressed as sum of 2 terms. And this is also expressed as sum of 2 terms in the entire first row. Now, the given determinant can be split as 2 determinants because here we are expressed as 2 terms right there. We can simplify it as that we can express as 2 determinants for this. So in the first row, it is of sum of 2 terms right here. So you can write the first terms. So for first determinant, write the first terms. A1, A2, A3, B1, B2, B3, C1, C2, C3. Okay, this is the first determinant. So plus. So second determinant. So what we can write? So in the R1, you have the second elements right there. So write the second elements. Alpha, beta, gamma, B1, B2, B3, C1, C2, C3. So this is the second determinant. So means in a determinant, if a row or a column, we can take it as a row or we can take it as a column, what it may be, can be expressed as sum of 2 or more terms, so that the given determinant can be split into 2 or more determinants. If it is in the first row, second row and third row, that both the determinants are same, so the first row will be changed. Suppose let us see in the column A1, B1, C1, A2 plus alpha, B2 plus beta, C2 plus gamma, A3, B3, C3. So now the given determinant can be split as 2 determinants because here column 2 can be expressed as 2 terms right there. So you can split it into the 2 determinants. Column 1 and column 2, the 2 determinants will be as it is. In the column 2, for first determinant you can write A2, B2, C2. For the second determinant you can write as alpha, beta, gamma with the plus symbol. Now see the first determinant. A1, B1, C1, A2, B2, C2, A3, B3, C3. So plus. So second determinant is A1, B1, C1, alpha, beta, gamma, A3, B3, C3. So this is the second determinant. See, A1, B1, C1. In these two determinants, first column is same. In the two determinants, third column is same. And the second column will be changed. The first determinant as the first terms and the second determinant as the second terms. So this is the property number 5. So what is the property number 5 is? It is a splitting of the determinant. If a row or a column or a column can be expressed as sum of or difference, whatever it may be. If it is plus, you can write here plus. If it is minus, you can write the minus here. So it is expressed as sum of two or more terms. So then the given determinant can be split into two or more determinants. It is property number 5. Okay. So next move to the property number 6. So what is the property 6 means? In a determinant, to any row or any column, the equi-multiples of corresponding row or column can be added. Then the determinant remains same. It will not change. Or simply it can be taken as. So in a determinant, if you apply the elementary operations like Ri changes to Ri plus k times of Rj, or Ci changes to Ci plus k times of Cj. If you apply the elementary operations like this, what is the new determinant obtained? That will not change. That is as it is as a given determinant. Okay. So let us see one of the example here. So let us take another delta. So what is the delta equals to A1, A2, A3, B1, B2, B3, C1, C2, C3. For this determinant, I am applying the elementary operation as R1 changes to R1 plus k times of R3. So this is the elementary operation I am applying to this determinant. If I apply this elementary operation to this determinant, the final answer should be as it is, as it of the given determinant. It will not change, it remains as it is. So let us see the delta 1. So what is the delta 1? Because you are applying elementary operation right here, so the determinant will change. So determinant of R1 can be taken as, you can add with R1 plus k times with R3. For the R1 row, you can write the elements of R1 plus k times of R3. So this is R1 right here. This is R3. So this and this and this are the corresponding elements. R1 is A1 plus k times of corresponding R3 is C1. Okay, next. R1 is A2 plus k times of corresponding R3 is C2. Next, R1 is A3 plus k times of corresponding R3 is C3. So take the corresponding elements of R1 and R3, R1 and R3, R1 and R3 and multiply with k. You wrote that R. What about R2? B1, B2, B3 as it is, C1, C2, C3 as it is. So you got this one. Now, shall I apply here property number 5? What is the property number 5? A row can be expressed as sum of two or more terms, then the given determinant can be split into two or more determinants. Here express the sum of two terms, so it is split into two determinants. Okay. So determinant of A1, A2, A3, B1, B2, B3, C1, C2, C3 plus what is the second determinant? You can write the next second elements KC1, KC2, KC3, B1, B2, B3, C1, C2, C3. See what is this one? This is same as a given determinant. So you can write this as a delta. Okay. Here in the first row you take k as a common. Okay. So taking common factor k from R1. From the R1 only you are taken the common factor. K if you taken the common factor, what is remain? In the first row you can leave all the k's. Okay. C1, C2, C3, B1, B2, B3, C1, C2, C3. So you are applying here property number 3. Or if you simply write R1 and R3. You can write like this: R1 and R3 are identical. So identical means the corresponding elements of R1 and R3 are the same, right? So what is the elements in R1? What is the elements in R3? All the elements are same, right? So that's why it is identical. If it is identical, the value of the determinant is 0. So this entire value is 0, right? So that equals to delta plus k times of 0. K into 0 is 0. So 0 plus delta is delta only. So see, delta 1, if you change also you get the same delta only, right? Means, so in a determinant, if you apply the elementary operations like Ry changes to Ri plus Krj, or Ci changes to Ci plus k times of Cj, the determinant will remain as it is. So this is the property 6. This is what discussed in the NCERT property. But remaining 2 more properties are there. So but that is not used in that textbook. But in the by solving the problems you can use that also. So what is that property means? So property number 7. So in a given determinant, if all the principal diagonal elements are 0, if all the principal diagonal elements are 0, then the value of the determinant is also 0. So means 0 A B, B 0 C, C A C. Okay, so it is the determinant. So in that, so what are the all principal diagonals? All are zeros, right? So the total value is also 0. Okay. Otherwise, if you expand this one, plus, minus, plus. Okay. For this, so first for 0. For 0 means you can get anything is 0 only. Next for minus A. First row, second column you can do. B into 0, 0. Minus C into C is C square. Next, plus B na, what you get? You get the cross values. What is the cross values? You can use that B into 0 minus C into C you got for the A. Next for this, B into A. AB minus 0. What the value got? It is 0. So this is minus and minus plus AC square. So this plus AB square. So what you got? AC square plus AB square you got. But what I said? So it is in a given determinant, if principal diagonal elements are zeros means it is 0. But it will not apply to all the problems. Okay? So you cannot take it for in the determinant. If you take the principal diagonals are zeros means all or cannot be 0, can be 0. No problem. Whatever it may be, you don't worry for that one. Okay? So for 0, 0 into 0, A into 0, you get obviously 0 only. For minus A, first row, second column, B into 0 is 0, minus C into C is C square. Next for plus B, next first row, third column, B into A is AB minus C into 0 is 0. Okay, this is the answer. But this is not used in any problem. Okay, so don't worry for this one. But just do about that property 6. That's enough. Okay, but in the problem I will explain one more property. But main property 1 to property 6 should be very, very important. So what is the property number 1? Property number 1 is in a determinant, if rows and columns are interchanged, the value of the determinant remains same. Second one, in a determinant, if any 2 rows or any 2 columns are interchanged, sign of the determinant changes. Third property, in a determinant, if any 2 rows or any 2 columns are identical, value of the determinant is 0. Fourth property, in a determinant, for any row or any column, you can multiply a non-zero number, that is Ri changes to k times of Ri, Ci changes to k times of Ci. You apply elementary operations like these are, you can multiply a non-zero number to a row or column, then the non-zero number can be multiplied to a whole determinant. Property number 5. In a determinant, A row or column can be expressed as sum of two or more determinants, sum of two or more terms. Then the given determinant can be split into two or more determinants. Next, property number 6. In a determinant, if you apply the elementary operations like this, Ri changes to Ri plus K Rj, Ci changes to Ci plus K times of Cj, the value of the determinant remains as it is. That is, delta 1 is equals to same delta. So these are the 6 properties. Okay. So based on these 6 properties, we can solve the problems. Okay. Okay, so let us see the problems based on that these 6 properties. So in that first one will be using the property of determinants. Property of determinants and without expanding. Without expanding, prove that the following questions. Okay. So what you can do means you can do without expansion only. In that, see the first question. Determinant of x, a, x plus a, y, b, y plus b, z, c, z plus c will be equals to 0. Okay, so this is the first one. So what you can do, see, using the property of determinants and without expanding, prove that the following. So you cannot directly expand. So by using properties only we can prove the problem. Okay. So solution, I took the left hand side. So means directly without expanding. By using properties only we can prove. So we cannot directly expand the given problem. If you directly expand means also you get 0 only. But by using properties of determinants and first without expanding, you can solve the problem. Okay, first one see here, LHS, determinant of x, a, x plus a, y, b, y plus b, z, c, z plus c. Okay, so what you can do, see, you can apply the property number 5 here. What is the property number 5? A row or a column can be expressed as sum of two or more terms, then the given determinant can be split into two or more determinants. So in that, so what you can do, column 3 can be write in the first and second determinants as a different, column 1 and column 2 in the first and second determinants as same. So what is the column 1? X, Y, Z, A, B, C. So again X, Y, Z. It is the first determinant plus second determinant X, Y, Z, A, B, C. Now you can write the second elements here. Second elements is again A, B, C. Okay. So now see here, in this problem, column 1 and column 3. See, all the corresponding elements are same, right? Column 1 and column 3 are identical. What is the meaning of identical? Corresponding elements same means the value of the determinant is 0. In this also, column 2, column 3. See, here also ABC, here also ABC. Column 2 and column 3 are identical. So what does it mean by identical? Means the total determinant is 0. That equals to 0 plus 0. You will get 0. Is the RHS. RHS 0 alva. See, you are applying the property number 5 here. What is the property number 5? In a given determinant, a column can be expressed as sum of two terms. Then the given determinant can be split into two determinants. In that column 1, column 2, column 1, column 2 is same in the two determinants, and column 3 will be changed. For the first determinant you can write the first element, for the second determinant you can write the second element. Now in that, apply the property number 3. Property number 3 means if two rows or two columns are identical, then the value of the determinant is 0. In that column 1 and column 3, corresponding elements are same, identical, 0. Column 2, column 3, corresponding elements are same, so identical. Therefore, the value of the determinant is 0. So this is the first question. Got it? How you can prove that the problems by using the properties of determinants. Okay. So move to the next one. Second one. A minus B, B minus C, C minus A. B minus C, C minus A minus B. C minus A minus B, B minus C will be equals to 0. Okay. So in this also see here we cannot apply property number 5 because here first row also explained, second row also and third row also, first column also, second column also, third column also. So for that what I will do means, so let us see the problem. LHS equals to determinant of A minus B, B minus C, C minus A, B minus C, C minus A minus B, C minus A minus B, B minus C. So this is the LHS. So what I will apply here means, I will apply that R1 can be taken as R1 plus R2 plus R3. I will explain the row, expanding the row as R1 plus R2 plus R3. So you can add this plus this means R1 plus R2 plus R3 add. I am writing in R1 only. Okay. So writing the corresponding elements. R1 is first element A minus B. Next R2 is B minus C. R3 is C minus A. Next again B minus C plus C minus A plus A minus B. Next again C minus A plus A minus B plus B minus C. Okay. So now B minus C, second as it is C minus A and A minus B. Next C minus A, next A minus B, next B minus C. Okay. Now plus A minus A cancel, minus B plus B cancel, minus C plus C cancel. Same plus B minus B minus A plus A minus C plus C, plus C minus C minus A plus A minus B plus B getting cancelled. So what is remaining? Determinant of 0, 0, 0. B minus C, C minus A minus B. C minus A minus B, B minus C. Okay. Now, so what is the one more property here means? In a given determinant, if any row or any column, if all the elements are zeros means the value of the determinant is also 0. So what is the property here? One more property. In a given determinant, if all the elements of a row or column are zeros, then the value of the determinant is also 0. So that is the RHS. Okay. If you expand a column plus minus plus also, obviously you get 0 only. So this is one more extra property. Means in a determinant, if a row or a column, all the elements are 0 means the value of the determinant is 0. So to make it as a 0, I am expanding, means I am applying the elementary operation like R1 plus R2 plus R. Okay, means first row plus second row plus third. First row, second row, third. First row, second row, third. Adding rows means adding top and bottom values. So this and this, top and bottom means rows. Left and right you can add means columns. So that's the main logic. Okay. If adding rows means you can add in the top and bottom values. If it is column means left and right values. So that is about the rows and column operation. So what is one problem? What the 0 right? Oh. So we'll move to the 1. So next question. Third one. Determinant of 2, 7, 65, 3, 8, 75, 5, 9, 86 can be equal to 0. So in this, first see what elementary operation you can apply. But what is the right hand side? To make it as 0. To make it as 0, what are the elementary operation you have? So you have the one elementary operation, that is property number 3. Means not elementary operation, is property number 3. 2 rows or 2 columns are identical. Identical means corresponding elements are same, right? So to make it as the same, first write the LHS. Afterwards you can see what elementary operation apply, what property you can apply. 2, 7, 65, 3, 8, 75, 5, 9, 86. Okay. See, a row or a column can be expressed as sum of 2 elements. Okay, see, these 2 can be represented in 65. It's not possible. Okay, let's see. 3 in 75, mostly 3 to the 65 it will go. But 2 will not go right. We will not take like that. 5, so it's not divisible with 6 or not with 8, not with so not with 9, not with 8, not with 7. So what I can do is, so this is the column right. I can split this one. How I can split this one means, so 2, 3, 5. Column 1 is as it is, 7, 8, 9. Column 2 is as it is. So this 65 is the right. In 7 table, so 65 is near to 7 9 is 63. Okay, means you will get 63 right. You will get 63 right with plus 2. 63 plus 2 65. So in 8 also we can take in terms of 9. 8 9s are 72. So you get 75 right. So that 75 can be taken as 72 plus 3. 72 plus 3 75 right. Now 86. If you take 9 in terms of 9 9s are 81. 81 with plus 5. Okay. Now, what we can apply? We can apply property number 5 here. What is property number 5? In a given determinant, a row or column can be expressed as sum of 2 or more terms. Then the given determinant can be split into 2 or more determinants. Okay. So, split this determinant. 2, 3, 5. Column 1, 7, 8, 9. Column 2, 63, 72. 81 is column 3. Next, again plus 2, 3, 5. Column 1, 7, 8, 9. Column 2, 2, 3, 5. Column 3. For this is, the answer is 0. Tell me what is this answer is 0? Because column 1 and column 3 are identical. Here also 2, 3, 5, here also 2, 3, 5. Right? The reason column 1 and column 3 are identical. Okay. So now this entire determinant is 0. Now for this one, so determinant of 2, 3, 5, 7, 8, 9. So 69, 63 can be taken as 7 9s are 63. 72 can be taken as 8 9s are 72. 81 can be taken as 9 9s are 81. So previous in the property 4 we explained, if any two rows or any two columns are proportional means if you taken that the division of R also in terms of multiple also you get the same elements, then the corresponding determinant is 0. Okay, see here, column 2 and column 3 are the proportional. So if you divide this element by this man, 9 and 8 cancel 9, this element by this element, 8 8 cancel 9, so this element by this element, 7 7 getting cancel, we get the same 9. We can say that column 2 and column 3 are proportional means so this also can be expressed in terms of these elements in terms of with the 9. Okay, otherwise, so in this column, take 9 as a common. Taking common factor, which one? 9 from which column? Column 3. This is column 3, right? I'm taking 9 as a common. If you take a 9 as a common from column 3, right? Column 2, column 1 as it is 2, 3, 5, 7, 8, 9. In this column 3, if you take a 9 as a common means remaining also 7, 8, 9 only. So in this column 2 and the column 3, so they are, what it means they are? So they are identical. If they are identical, determinant is 0, right? So 9 into 0, you will get 0. This is the RHS. Got it? Because here column 2 and column 3 are identical. That's why the value of the determinant is 0 according to property number 3. So 9 into 0 is 0. That is the RHS. Got it? Okay. We'll move to the one more. See that? One more. So fourth question, determinant of 1, 1, 1, BC, CA, A into B plus C, B into C plus A, C into A plus B will be equals to 0. Same, take on the left hand side. So LHS, first write the solution. Write the LHS. LHS equals to determinant of 1 BC A into B plus C, 1 CA B into C plus A, 1 AB C into A plus B. Okay. Here also column 3 can be expressed as 2 terms, but for this you are multiplying with one term, right? First of all you can multiply that term, afterwards let's see. So 1 BC A into B is AB plus A into C is AC. 1 CA B into C is BC plus B into A is BA. 1 AB C into A is AC, C into B is BC. Now we can split it, but instead of I will split, I can add these two. Why I can add these two means, if I add this and this, AB plus BC plus AC, this and this means AB plus BC plus C or AC both are same. Again this and this means AB plus BC plus AC. You will get all the elements are same, right? You can take that as a common means you will get 1 1 1, here 1 1 1, obviously it is identical. So for that what I will apply, column 3 can be changed as column 3 plus column 2. So in place of column 3, write the corresponding elements of column 3 with the addition of the corresponding elements of column 2. 1, 1, 1. Column 1 as it is. BC, CA, AB. And column 3 can write as, so this and this write as, so this plus this, this plus this, this plus this, we can write in the column 3. AB plus BC plus AC. So I am writing in that order. AB plus BC plus AC. AB, BA both are same plus BC, CAC both are same. AB plus BC plus AC. Again this plus this. AB plus BC plus AC. AB plus BC plus AC. Got it right there. So what I will do here? Taking common factor AB plus BC plus CA or AC from column 3. From entire column 3, I will take the term as a common. That equals to, what is it common? AB plus BC plus CA as a common from the column 3. What is the column 1? 1, 1, 1. Column 2. BC, CA, AB. Column 3, you took this as a common, right? 1, this as a common, 1, this as a common from entire column 3 means you get 1, 1, 1. Here, column 1 and column 3 are identical. So, identical means you get 0 right there. That equals to AB plus BC plus CA into 0. That is also equals to 0. 0 anything is 0 only right there. So that is the RHS. Got it? If I split this one means you will not get that exact answer. So that's why I took the addition of the column 3 with the column. Got it? Here we can do the one more column. Determinant of zero A minus B minus A 0 C B C 0 can be equals to 0. Okay, so at the time of explaining the properties, I explain like property number 7. If diagonal elements are 0 means the value of the determinant is 0, I explained. But the answer I am explaining for that answer is not getting 0. But for this problem, the answer is 0. Let's see whether the given answer will be correct or not. So according to the, so question is minus B, minus A, minus C. It is minus. Okay, so this is already you know about the symmetric and the skew symmetric. What is that symmetric matrix? Symmetric matrix means transpose is same as a given, and skew symmetric means A dash is equals to minus A. Okay, so based on that concept only we can say whether the principal diagonals are zeros means the value of the determinant is 0 or not. Okay, for that I will took the LHS. Or let us take that determinant as a delta. Okay, so what is the delta? Delta can be taken as a determinant equals to 0 A minus B minus A 0 minus C B C 0. Okay, this is the determinant. So now from that R1, from that R2, from that R3, I will take that minus as a common. So okay, taking common factor minus 1 or minus from R1, R2 and R3. Okay. So now what we get? We get minus 1 whole cube. Why it is minus 1 whole cube? Because you are taking how many times, sir? You are taking the 3 times as a minus common, right? From where? From R1 and from R2 and from R3. That's why you will take whole power of 3 times. If you take from R1 R2 minus 1 whole square. Only from R1 just minus 1. So you have taken from the 3 rows, right? That's why you get minus 1 whole cube. So in this minus as a common 0 minus a b. Next a 0 c. Next minus b minus c 0. So you got this one. What is minus 1 whole cube? Minus 1 whole cube is minus 1, right? Delta can be taken as minus determinant of 0 minus a b a 0 c minus b minus c 0. So now see, this can be written as a delta. Let's see. So 0 minus a b a 0 c minus b minus c 0. Okay. So it is already, you have the minus. Is it same as a delta? No, because what you got here? 0a minus b, but here 0 minus c. A 0 c, here minus a 0 minus c. Minus b minus c 0, here b c 0. Is it as a delta? So no. So for this, if you multiply any term, what you will get? To make it as a 0, what you can do? You can make it as that property 3, means 2 columns are identical or all the elements are 0, like that you can do. But here you will get any concept like this, so no. So to make it as that 0, you can apply any operation. So which elementary operation you can apply? But to apply any elementary operation, any row or any column must be 0. So in that you will get any row or any column are 0. So no, right? So you can apply any elementary operation. So for this, if I multiply with minus, what will you get? If you multiply this minus means 0, minus a becomes plus a and minus b. Next, minus a 0 minus c. Minus into minus plus b plus c 0. Will get like this. So this and this becomes the same as it is if you multiply with the minus. So now, what was the procedure you can apply? So what is the condition? So I took that minus 1 from R1, R2 and R3. So from this side. Okay, but again what is it getting here? It is getting again that same answer only, because if you multiply with minus again you will get the same answer. But to make it as a 0, you can apply element operation. See, I will multiply this minus. So delta will be equals to. So minus into 0, 0. Minus into minus is a plus a, minus into b is a minus b, minus into a is a minus a, minus into 0 is a 0, minus into c is a minus c, minus into minus is a plus b, minus into minus is a plus c, minus into 0 is a 0. See, what is a delta? What is a delta? Both are equal. Is it equal, right? Now, what you can do? Suppose if I will directly expand, so plus, minus, plus, what should be answer? It should be 0. But see, according to the problem, what we can do? We cannot directly expand. But first of all, I am expanding whether the answer should be 0 or not. For that 0, we can leave the first row, first column. 0 into 0 is a 0. Then minus c into c square. That minus becomes plus c square. Or if you multiply 0, is also no problem. Okay. Then minus into a, minus a, first row, second column. Minus a into 0 is a 0, minus b into minus c is a minus bc, so this minus becomes plus bc. Next, plus into minus minus b, first row, third column. Minus a into c is a minus ac, b into 0 is a 0. So this 0 into anything is 0, okay, you can leave. Minus a into bc is a minus abc. Minus into minus is plus ABC. So is minus ABC plus ABC getting us to get 0, right? But the answer is getting 0. But what you are doing here? Here you are doing by the expansion. But according to problem, what you can do? You cannot do by expansion. So okay. So for that we can apply any property. Okay. See which property you can apply. You should compulsory apply the property. If you apply property only, you can solve problem. Means question they are asking means you can using the property and without expanding only you can solve the problem. Okay. So delta equals to 0 a minus b minus a 0 minus c b c 0. To make it as a 0, what elementary operation you can apply? Okay, I will apply that elementary operation as R1 changes to R1 plus R1 plus b times of R2. R1 can be changed as R1 plus b R2. So what is that R1? 0 plus b into R3 is b square. So a plus b into c. So a plus bc. Again minus b plus b into 0 is minus b. So minus a 0 minus c. So b c 0. So again what you can do? So you can apply elementary operation right there. So in this property, in this problem, what you can do? So in this splitting of two terms, but here there is no splitting of two terms right there. We cannot do. Okay. Now here is there any common? So no. So you cannot apply R1 changes to R1 plus BR. Okay. We can leave that one. So R1 changes to R1 plus BR3 you cannot do. Then what you can do? So by using that concept of so previous what we did right there. So like that only we can continue. So how we can continue means so multiply. What we can do? Multiply by minus for other taking common factor minus 1 from R1, R2 and R3. So delta will be equals to, so minus 1 whole cube you got, that is 0 minus a b a 0 c minus b minus c 0. Minus 1 whole cube is minus 1 only. Delta equals to minus of 0 minus a b a 0 c minus b minus c 0. Okay. Afterwards we can expansion because we are applying the properties right there. So that equals to. So for the minus, first one 0 of. So 0 of 0 anything is 0 only. Next minus into minus plus a. For the plus a we can use the first row, second column. A into 0 is 0 minus c into minus b is minus, here becomes plus bc. For plus b. Okay. First row, third column. A into minus c is minus ac. 0 into minus b is it is minus 0. So that equals to. So minus of 0 into internal is 0. A into bc is abc. B into minus ac is minus abc. Plus abc minus abc is 0. We will get 0. So previous problem also we did that. Previous also we did the direct expansion. But why you can apply this means properties of determinants. First of all, you can apply properties only. Afterwards, you can expansion. So means without expand means directly you cannot expand. Directly you can expand also you get the 0. But by using property also we can prove the given problem by expanding. But directly you cannot do the expansion. If you apply any property afterwards you can expansion is no problem. But we cannot do by directly. Okay. So this is how we can solve the problem. So this is by using the properties of determinants. Okay. So now we can do the main 4-mark question. Okay. So got this one? So don't confuse here. So previous I did means so just by directly expanding. But here I applied a property. So taking common factor multiply, so one of the property only. Afterwards multiplying and afterwards expanding also will get the same answer. Okay. So next main thing is by using properties of determinants. Okay. So these are very important for the 4 marks questions. But so how you can solve means that should be mainly purely based on that properties only. If you don't know the properties means you cannot solve that one. Okay, so I will explain the problems. Now, next class we will do how we can solve the problems on that one. Okay, simply I will explain what is the logic there. So, determinant of 1a square, 1b square, 1c square will be equals to a minus b, b minus c minus a. And the second question, determinant of 1, 1, 1, a, b, c, a cube, b cube, c cube equals to a minus b, b minus c minus a into a plus b plus c. Next, third question, determinant of x plus 4, 2x, 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 x plus 4, 2x, 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 x plus 4 will be equals to 5x plus 4 into 4 minus x whole square. Next, determinant of y plus k, y plus k, y. So y plus k will be equals to k square into 3y plus k. So the next question, determinant of a minus b minus c, 2a, 2a, 2b, b minus c minus a, 2b, 2c, 2c, c minus a minus b. So will be equals to a plus b plus c whole cube. Next, x plus y plus 2z, x, y, z, y plus z plus 2x, y, z, x, z plus x plus 2y will be equals to 2 times of x plus y plus z whole cube. Okay, so like this there are some of the problems. But how you can do problems like this means, see, you can take the LHS and you can do the RHS. If it is 3 cross 3, you can apply maximum 2 elementary operation. If it is 2 cross 2, you can apply maximum 1 elementary operation. So it is 3 cross right, you can apply maximum 2, you cannot apply 3. To make it as a minus b, so we have that a minus b, and a minus b barbekanದ್ರೆ, you can subtract that. So this minus this right, it is in which row? So it is in R1, it is in which row? It is in R2. We can subtract means a minus b, we will get a minus b right. So R1 can be changed as R1 as R2. To make it as b minus c, so now b minus c, so this is b, this is c right. So b minus c means you can subtract this minus this. So b is in the second row and c is in the third row. So that is, you can change as R2 minus R3. If you subtract R2 minus R3, you will get b minus c. If you subtract R1 minus R2, you will get a minus b. So a minus b, to get a minus b, you can apply R1 minus R2. To get b minus c, you can apply R2 minus R3. You will get that one. Afterwards, we can apply any elementary operation or we can directly expand. Okay. Next, a minus b. So you can apply this minus this right. To left and right, you can apply columns. Top and bottom, you can apply row operation. It is in left and right, it is in column 1, it is in column 2. To make this a minus b, you can apply the elementary operation c1 minus c2. If you subtract these two means, you will get a minus b. Same like, to get b minus c, subtract this and this. So this is in column 2, so this is in column 3. So c2 minus c3, apply the elementary operation as column 2. So you get b minus c. So after that, we can apply for these two. Either we can apply any elementary operation or we can expand, no problem. But starting, we can apply a elementary operation. Okay, by using properties, and afterwards we can expand. Okay, now see here. So 3, 4, 5, 6, they are all similar process. See, in this, in the R1, 2 elements are same. In the R2, 2 elements are same. In the R3, 2 elements are same. In a problem, if 2 elements in row or column are same, in the row or column are same, you can apply the elementary operations like R1 changes to R1 plus R2 plus R3, or C1 changes to C1 plus C2 plus C3. Not only R1, you can write R2 as also same, R3 is also same, C1 as also same, C2 is also same, C3 is also same. So this is when the two elements in the row or two elements in the column are same. See, in the problem, so first row also two elements are there, first column also two elements are there. You can apply R1 changes to R1 plus R2 plus R3, or you can apply C1 changes to C1 plus C2 plus C3. So same see here. So for this also, if you apply this one means, so this is the simple logic here. C2 changes to C2 minus C1, C3 changes to C3 minus C1. If you apply R1 changes to. If it is C1 changes to, you can apply R2 changes to R2 minus R1 as well as R3 changes to R3 minus R1. So this and this is very easy. But if you apply this one means, so the what is that on the right hand side, that must become. If simply the two elements are same or in the row or two elements are same in the column means, if you apply this means, if you not get on the right hand side means, you cannot apply that one. Okay. If you apply that elementary operation means, if you add the elements in the first row, if you taken that common, that should be present on the RHS. Otherwise, you cannot apply that one. If you apply also, then there is no use. Okay. See here also. In the first row, two elements are same. Second row, two elements are same. Third row, two elements are same. Column also two elements, column also two elements, column 3 also two elements. You can apply as R1 or you can apply as C1. If you apply this one means, this is okay. If you apply this one means, this also will get up. If you apply means, the problem will be easier. Now go to the fifth one. See, on the right hand side you will get ABC. So same logic I applied here. In that R1, two elements are same. R2, two elements are same. R3, two elements are there. When you compare to column 1, so there is no common elements. So here in case of getting in R1, R2 or R3. So R1 two elements are same, right? You can apply the elementary operation as R1 changes to R1 plus R2 plus R. In this, if you apply this one means, obviously you can apply. So why you are this apply means, this apply means, if you apply this one means, the problem will get easier instead of applying that some other elementary operations. Move to the sixth one. See, R1 there is no two elements same. R2 there is no two elements same. R3 there is no two elements. Column 1 two elements are same. Column 2 two elements are same. Column 3 two elements are same. So that is, you can apply the elementary operation as C1 changes to C1 plus C2 plus C3. If you apply this one means, what is the common you are getting in the column 1, that must be present on the RHS. If you apply this one means, what is the common you are getting from the R1, that must be on the right hand side. Okay. If you apply this one means, so this is elementary operation will be easy to solve the problem. Got it? So this is how you can do the problems based on the properties of determinants. Okay. So in the next class, we can do the properties. So problems on these properties of determinants. So these are very important for the 4 marks questions. Okay. See, by using properties of determinants means, you must compulsory apply the properties. After properties, you can expand, no problem. But first of all, you can apply properties, then only you can expand. But without properties also, you can expand this one. But for the 4 marks, they will ask by using properties. Using properties only, you can prove that LHS is equals to RHS. Okay. So in the next class, we can discuss the problems like this by using the elementary operations. But main thing means, you know how to add the rows, how to add the columns. To add the rows, top and bottom. To add the columns or to subtract the columns, left and right. If you add in left and right, column operations. If you add in top and bottoms, row operations. That's it. That's the main thing. Okay. So in the next class, we can discuss on the same concept. Okay. Thank you.